Exponential equations in hyperspeed, 5 minutes. Let's go. Level 1. So I have an exponential equation, 16 to the x plus 1 equals 256 to the x minus 1. I could graph the left side, graph the right side, find their intersection, and I would find that the intersection is 3. I can type it into regular Desmos, and it gives me a vertical line at x equals 3. So the answer is 3. The answer is 3. The answer is 3. Okay? But that's not what matters. What matters is the process. So how can we prove that the answer is 3? Well, this is going to be the best skill that you have for these types of exponential equations. You need to take a look at the two bases that you have, 16 and 256. You need to ask yourself, those two numbers are an output of what power? An output of what power? In other words, for example, 16 is a power of 4 squared. 256 would be a power of 4. So you want to find the largest base that this could be an output of as far as exponential powers. That's redundant. But after a little bit of digging, I find, well, they're both powers of 16 because 16 is 16 to the first. 256 is 16 squared. So at that point, you can, here you go, replace your 256 with a 16 squared. All right, that's substitution because they're equivalent. Now, after a little bit of memory, you have an exponent that is raised to another exponent, which means you can multiply those exponents. So I'm going to simplify my equation now to 16 to the x plus 1, which the left side remains the same. On the right side, I now have 16 to the 2x minus 2. So then you arrive at this really neat conclusion that says, if I have an equation and both bases are the same, then that must mean that the two powers must be the same. And they are. So x plus 1 equals 2x minus 2. This boils down to a puny little linear equation, all right? That when you solve it, you get x equals 3, all right? And that's pretty much it. That is how you solve a level 1. Let's move on to level 2, all right? Once again, you can graph it to find the answer. Apparently, the answer is -1. Let's see why. So 262,144, as well as, and I'm not going to look at this as 1 over 512. I'm just going to look at it as 512 because I know that it's the reciprocal, so it'll be a negative exponent. Regardless, I need to think what number would give me 512 as an output, also 262,144. And after some digging, I had to play around with it. I found that 8. Both of these numbers are powers of 8. For example, 262,144 is the 6th power of 8, while 512 is the 3rd power of 8. That means that 1/512 is the -3rd power of 8. So I substitute, and I've got 8 to the 6th raised to the x minus 2 equals 8 to the -3rd raised to the -3x plus 3. I'm going to follow the same process that I did last time. I'm going to multiply my exponents. That's called the power property. And once again, I'm left with a linear equation that when I solve it, all right, by subtracting 6x and adding 9 and all that good stuff, I get x equals 1. So same deal, just more complex numbers for a level 2 type of problem. Now here's a level 3 type of problem, all right? The only thing that makes this level 3 is we can add in some quadratics into the mix, right? 1/25 and 5, well, 25 and 5 are both powers of 5, all right? 1/25 is the -2nd power of 5, while 5 is the first power of 5. So, and the way to remember that is if 25 is the 2nd power of 5, then 1/25 is the -2nd power of 5. So once again, I carry out my power rule. So that is the same. And I end up with 5 to the 12x minus 6 equals 5 to the -3x squared plus 9. All right. Now that I have my common bases, my bases are equivalent in an equation. My powers must be equivalent. So I say 12x minus 6 equals -3x squared plus 9. That's a quadratic equation. And we've been doing those all semester. You're never going to get away from them. So I am going to set that quadratic equation equal to 0. Extract the GCF. All right here in cell number 30, I extracted a GCF. At that point, I factored my quadratic to x plus 5 times x minus 1. And I arrived at the answer x equals -5 and x equals +1. And those are the two solutions to that exponential equation. Pretty neat, and all in 4 minutes and 35 seconds. I don't know. All right. Best of luck working these out. They're not bad.